Okay, so what we're covering in this section of notes is properties of logarithms. And what's nice about logarithms is you actually know the properties, but now they're just written differently because you know what they look like as monomials. So an example would be if I tell you we have a to the fifth times a to the second, that would be a to the 5 plus 2, which is a to the seventh. What we do with logarithms is we take that same idea. So when you multiply things, you end up adding them. Okay? So for logarithms, if I have log base 5 of 2x, right here, this is actually a multiplying. So that means I'm going to be adding them. I don't have enough space in the box. So it'll be log base 5 of 2 plus log base 5 of x. And so multiplying turns to adding. Okay. The quotient property is if we had a to the fifth. Oh, look at that. A to the fifth divided by a squared. I have 5 on top, 2 on the bottom. So I would do 5 minus 2, which is a to the third. So for quotient, when you're seeing dividing, you're going to subtract. So what that looks like here is log base 5 of 2 over x. Since it's a divide, we're going to subtract. So it'll be log base 5 of 2 minus log base 5 of x. If you notice, the logs part stayed the same on each of them. The log doesn't change. What matters is that if you see things next to each other, that means it's multiplying, and for multiplying you add. When you see things as a fraction like dividing, you're going to subtract. The last rule that doesn't really look the same in monomials is if I have an exponent. So if I have log base 5 of x to the third, this is what we do. We take this exponent and we move it to the front. So it becomes 3 up front times log base 5 of x. So I just moved the exponent. Okay, so let's go ahead and do some of these problems. I can't believe that I have the exact same example here as I did here. This was just by chance. So let's actually cross this one off. Let's make it log base 7 of 3y. So again, this is timesing. So when you see a times, you're going to add. So it's log base 7 of 3. Where my times sign is, I write a plus. And then I write my log again, log base 7 of y. And that's the answer. For number 2, ln is this the natural log. It's a different type of log, but it follows the same rules. If you notice, we see a divide. So that means I'm going to have to subtract. And so it'll be the natural log of 5 minus the natural log of x. Okay, for this one, you should recognize that there's an exponent. And remember, exponents go to the front. So it'll be x log base 3 of 4. And that's it. Okay, when we look at the next type of examples, what we're going to do is we're working backwards. Okay, we are going to do, you see there's a 2 in front, so that means it has to come to the exponent. And you see a plus sign here, so a plus sign means that I'm going to be timesing. Okay, so I'm just going to have the one log, because remember our base stays the same. I have log base 2 on both of them. So that's what I have as my base, log base 2. I start with a 5, and remember I moved the 2 over, so it's 5 squared, and then it's times x. And we're going to simplify it so it doesn't look like this, and the answer is going to be log base 2. 5 squared is 25, so it's 25x. And that's the answer of how you condense it. When we look here, same idea. Anything in front becomes an exponent. A minus means that I'm dividing, so I know I'm going to have a divide by sign. And so my bases are the same again. Natural log, that's the same base. So it'll be the natural log. Ooh, what is that? The natural log, and whatever comes first, since 5 came first, it has to go on top. And remember, we move the x to the exponent, and then divide it by 8, and that's the answer. Okay. When we do problems like 6 through 8, your calculator does not have, a lot of times your calculator does not have the function to do this. And so what we do is we're going to figure out, they all have log base 2, right? And so we're going to figure out, how can I make my number based on a 5 and a 3? And so what this is this is going to be log 2. I got to get a 15. The only way I can get a 15 is by multiplying. 3 times 5. Okay, so now that tells me it's log base 2 of 3 plus log base 2 of 5. Because again, multiplying means that I'm adding. And now what I'm going to do is I'm just going to plug my numbers in. Log base 2 of 3 is 1.585 plus log base 2 of 5, which is 2.322. And then you're going to add them together. So when you use your calculator to add those, you get 3.907. Okay, so for this one, it's already set up 3 divided by 5. Remember, divide means I'm going to minus. So it's going to be log base 2 of 3 minus log base 2 of 5. Well, log base 2 of 3 again is 1.585 minus 2.322. Okay, so now let's use our calculator. Let's clear it. 1.585. Oops, that's not a 1.585 minus 2.322. So negative 7.37. And that's the answer. Okay, for this one, again, you have to think, how can I use a 5 and 3 to get 125? Well, and a 5 and 3 to get 125 is log base 2 of 5 to the third. And so the 3 is an exponent, so it comes in front. So it's going to be 3 times the log base 2 of 5. Well, log base 2 of 5 is 2.322. So it becomes 3 times 2.322, which is 6.966. And that's the answer. Okay, change the base formula on your calculators. Sometimes you have to find the decimal, and you may not be able to change the base. The calculator, when you see a log, naturally has base 10. And so sometimes our problems are not going to have a base 10. So this is how we do it. I take the log. So if I have log base 5 of 8, if I follow this formula, you see how I have a outside. So it's going to be the log of 8 over the log of c. Not c, but 5. And so we'd have to use our calculator to find that. I don't think, let's see, maybe I got a scientific. Does it have logs? Oh, there it is. So log of 8. Oh, this is one where you have to go backwards. So 8 log. Okay, so that's 0.903. Let's clear it. And then I have to do 5 log 0.699. And now I have to divide. So 0.903 divided by 0.699. 1.29. That's the answer. So if you don't have a calculator that can change the base in it, this is how you're going to do it. Okay, what I'd like you guys to do is I'd like you to try and do problems 1 through 4. For problems 1 and 2, you're going to be expanding it so you'll have pluses or minus. On problems 1 and 2 on the second one, you're going to be condensing it so it's all with one log or one natural log. Okay, so there's a couple things you should have noticed. You should have noticed that there was a times, so I know I'm going to plus. And there's an x squared and a y to the 4th. So that means I have to fill in 2 blanks because there's only 2 things. Now when I look at this first one, x squared is going to go to the front. So that means it's going to be 2 log of x. When I look at this one, their exponent's also going to go to the front, but it only goes to the front of the y expression. So it'll be 4 log y. Okay. This one, if you notice, has 3 things. It has a timesing and a dividing. So the first 2 timesing mean I'm gonna add, and then the last one's dividing, so I'm gonna subtract. So I think about it, those 3 things. So the first number I have is just 2, so it's the natural log of 2. The second thing I have is x to the 4th. Remember, exponents go to the front, so it'll be 4 natural log x. And then the last one is just a 5, so minus natural log of 5. And that's the answer. All right, on the second numbers, we kind of have to condense things. So I know I'm going to be timesing and then dividing. So this goes up here. So I have log base 3. It'll be 4 squared times the next one. This is an exponent. It goes here. X to the 3rd. And then this last one is minus, so it's divide by 5. And so now I just want to condense this so it looks a little prettier. 4 squared is 16, so it's going to be 16x to the 3rd over 5. Okay, last one. Again, this one has just pluses, so that means they're going to be all times. But I'm going to be timesing 3 things together. So it's going to be the natural log, this is just a 2, times, this one's going to go, this exponent goes here, y to the 3rd, and this exponent goes here, z to the 4th. So just to make it look nicer, I'm going to rewrite it without the time signs. And that's it. So it's a little tricky, but if you take one step at a time, it makes it an easier problem to solve.